Okay, so previously I talked about how to test for differences in one slope across groups. And in this video, I'm going to talk about how to test for differences in regression functions across groups. And we're going to talk about how to test whether all slopes are different across two groups. Now this is different than the previous example that I showed you where only one slope it differed across men and women. And in this example, we want to test the null hypothesis that two groups follow the same regression function against the alternative that at least one of the slope differs across these two groups. And I'm going to use GPA3 dataset for this example. I'm going to regress our model where our cumulative GPA is our dependent variable, and we want to test whether this cumulative GPA it differs across female and male. And our other variables in the model are SAT scores, high school percentages, and total hours prior to term. And we are going to interact all these variables in the model with this dummy variable female so that we will get all these variables separately as well as interacted with this female dummy variable. And then I'm going to subset my data only for the spring semester. We want to test whether all of these slopes differ across these two groups. So our null hypothesis here is that the cumulative GPA follows the same model for males and females. That is, all of these highlighted interaction terms, they are equal to 0. So this will be our null hypothesis that none of these interaction terms are statistically significant. So we find that this interaction term between dummy variable female and SAT score is statistically significant at 5%. So what we can do is we can test the F-test that whether all of these interaction terms are statistically significant jointly or not. So let's go ahead and use the library car, and we're going to test our null hypothesis that all of these three interaction terms are equal to 0 using the linear hypothesis function that I introduced to you earlier. So our null hypothesis again here is that all of these terms are equal to 0, and we are rejecting this null hypothesis at about 20%, which means we do not have a strong evidence that at least one of these interaction terms has any statistically significant impact on cumulative GPA, which means we find no evidence that cumulative GPA model is different for female and male. That is, the slope for SAT, high school percentage, and total hours prior to term, their slopes are different across men and female, so we do not need to include these interaction terms in the model. A more appropriate model will be a model without these three interaction terms. Hence, we included only the dummy variable for female, which means only the intercept is different across these two groups, but the slopes of these three coefficients are identical across men and women. We can use these dummy variables and these interaction terms to test for whether all of the slopes are identical across groups. Alright, I'll see you in the next video to talk about linear probability models.